The luckiest coincidence in the sky. The sun is 400 times wider than the moon, and it sits 400 times farther away. Same number, both directions, which means in your sky, measured edge to edge, they are exactly the same size. Nothing in physics requires that. No rule, no reason. Today, the luckiest coincidence in the sky, and why it won't last forever. Welcome back to What and Why. 10 days ago, the moon covered the sun rim to rim, like a lid made for the pot. And on Tuesday, we worked out when the sky allows that. Today is the stranger question. Why does a little moon fit a monster sun at all? Two numbers. One ridiculous fluke. Start with a trick you own already. Hold up your thumb. There's a mountain on the horizon, 1 billion times bigger than your thumb, and your thumb wipes it out of the sky. We use this in the moon series, and it's the whole secret. How big something looks depends on two things at once: how big it is and how close it is. Small and near can look exactly as big as huge and far. Watch, as the ball slides away, it looks smaller. Slide it close, it looks bigger. Keep it on the same lines and it never changes at all. Astronomers have a fancy name for how big it looks: angular size. And the moon is running the thumb trick on the sun. Here's the fluke in numbers. Width first. Line up moons across the face of the sun and you'd need about 400 of them. That little dot next to the sun, that's the moon drawn to actual scale. Now distance. For every step to the moon, it's about 400 steps to the sun. 400 times smaller, 400 times closer, divide, and the two 400s cancel out. What's left is a perfect fit. Two disks exactly the same size in your sky. No law of physics says those numbers have to match. Mathematically, it's a shrug, pure luck. Well, roughly 400, and that roughly is about to matter. Because the moon's orbit isn't a circle, it's an oval. Some weeks the moon rides farther from us, some weeks closer, and its size in the sky breathes in and out with it. Catch an eclipse when the moon is on the far side of its oval, and it's a touch too small to finish the jog. It blocks the middle of the sun and leaves the edge blazing, a ring of fire. It already happened this year. February's eclipse was a ring. And careful, that ring is still the surface of the sun, so for a ring eclipse, the glasses stay on the whole time. But catch the moon on the near side of its oval, and it covers the sun with room to spare. Totality lasts longer. That's not luck, that's what you got. On August 12th, the moon had swung close, and totality stretched to 2 minutes 18 seconds. You didn't just see an eclipse, you saw a good one. Now the part that changes how you see all of it. Astronauts left mirrors on the moon, and we've been bouncing laser beams off them for 50 years. It's how we know the moon's distance down to millimeters. And the number moves. Every year, the moon is 3.8 centimeters farther away, about as fast as your fingernails grow. So run the clock forward, millions of years, hundreds of millions, and the moon slowly shrinks in the sky. One day, it will be too small to ever cover the sun, even on the near side of its oval. Somewhere around 600 million years from now, someone will stand in a shadow and watch the last total solar eclipse in Earth's history. After that, rings. Only rings forever. Don't worry, 600 million years is a long, long way off. But the countdown is real, and it is already running, which means you live in a special time. Long ago, back when dinosaurs were doing the watching, the moon rode closer, so it looked bigger, and totality ran longer. In the far future, our descendants get rings, and only rings. And right now, the moon is at the exact distance where it just fits. Close enough for totality, far enough that the fit is perfect, with the corona blooming right at the rim. Astronomers have a phrase for this stretch of time, the Eclipse Era. You didn't choose to be born in it, you just were. Lucky you. And in case that doesn't feel rare enough, look around the neighborhood. Mars has 2 moons, and for Mars, you'd think that doubles the fun. It doesn't. Phobos is a lumpy little potato, 20-some kilometers across, racing around Mars so fast it crosses the sky in hours. When it passes the sun, it covers maybe half of it, a lumpy dot photobombing, gone in half a minute, never a fit. And Deimos is barely a dot at all. One planet in this solar system gets the rim-to-rim, corona-blooming, day-goes-dark show. Ours. Lucky us. One more twist before the wave says goodbye. All month, the moon has been the one casting the shadow. But Earth casts a shadow too, and Earth's shadow is huge. Sometimes the full moon sails right into it. Sunlight cut off, the moon should just go dark, but it doesn't. It turns red. Deep, quiet copper red. And this is not a someday thing. It happens this Thursday night, August 27th into the 28th. Tuesday in the wave finale, I'll show you exactly why it turns red and how to watch. No path, no glasses, no equipment, just a window. So remember, 400 times smaller, 400 times closer. That's why the moon fits the sun in your sky. The orbit's an oval. Close moon means total. Far moon means a ring. And the moon is drifting away, a fingernail's growth a year. So enjoy the era. The sky saved its best coincidence for you. That's the Eclipse Wave, episode 7 of 8. Thursday night, the moon turns red. Tuesday's finale shows you how to watch it from anywhere, no glasses needed, and wraps the whole wave. Subscribe so you don't miss the ending. See you on What and Why.